Here's a third example of completing the square. I will caution you, in this example, we're going to work with some messy fractions. So if you're not comfortable with adding, subtracting, multiplying, and dividing fractions, especially those with unlike denominators, then this video probably is not for you. But if you want to dive in head first, come along for the ride. Now in this quadratic formula, it's not a quadratic formula, in this equation, the squared term is not 1. The squared term does not have a coefficient of 1. To complete the square easily, we really need that squared term to have a coefficient of 1. We also, as in previous videos, need to get rid of the constant term. Let's get rid of the constant term first. Let's add 4 to both sides. So now we have 3x squared minus 11x, and again I'm going to leave some space, equals 4. Now I need to get rid of that 3, and I'm going to divide everything by 3. Let's use some color here. Remember that when we divide in an equation, we can't be selective about what we divide. This would be illegal. We have to divide everything by 3. So my new equation would be x squared minus 11 thirds x, and again I'm going to leave some space, equals 4 thirds. Now remember the math that we had done before. We have to take half of this term and then square it. So let's do the math. We have negative 11 thirds. Half of that is like multiplying by 1/2. So half of negative 11 thirds is negative 11 sixths. And the math is going to get kind of interesting here because we then have to square this to get the term that we're going to add. This is going to be 121 over 36. And that's the term that we're going to add to both sides. So we're going to add 121 over 36 to both sides of the equation. And you really need to be comfortable with fractions for this to work out nicely. Now on the left side of this equation, what we actually have is a trinomial that is a perfect square. Now if you remember the math up here, negative 11 sixths was kind of important. Negative 11 sixths was half of negative 11 thirds. This is actually going to work out to be x minus 11 sixths. And this quantity is being squared. And on the right, we have two unlike fractions. We really need to get a like denominator. In this case, we're going to multiply by 12 over 12. 4 times 12 is 48. 3 times 12 is 36. And now we can add these two fractions. So let's switch colors. Now what we're going to do is take the square root of both sides. Well, first let's finish up the right-hand side. 48 plus 121 is 169, and the denominator was still 36. And over here we had x minus 11 over 6 quantity squared. Now it's really important that you understand that we've now gotten x all by itself. Well, it's not all by itself yet, but there's only one version of x in this entire problem. And so we can solve for that. The first thing we need to do is take the square root of both sides. So I'm going to take the square root of the left and the square root of the right. Remember that when you take a square root, you need to use the plus or minus sign. So what do we have over here on the left? The square root of x minus 11 quantity squared is just x minus 11 sixths. Over here on the right, we have plus or minus the square root of 169 over 36. Well, if you recognize 169, that's actually 13 squared, and 36 is 6 squared. So the square root of that is simply going to be plus or minus 13 sixths. And now we're almost done. All we have to do is add 11 sixths to both sides. And we get x equals 11 sixths plus or minus 13 sixths. And again, this is two different answers. So let's take a look at what these answers are. We have 11 plus 13 over 6. So on the one hand, x is equal to 11 plus 13 is 24. So x equals 24 sixths. And on the negative side, x would equal 11 minus 13 over 6. Well, 11 minus 13 is a negative 2 and over 6, negative 2 sixths. So our final answer, 24 sixths, is 4. X equals 4, or x equals negative 1/3. And we're done.